All right, this is Susan Poss again. This is the last video from section 2.5 where we're talking about solving equations. All the equations that I've worked for you previously are called conditional equations. I think I mentioned that because they all had a single solution, a finite number of solutions. Not all equations have just one. Linear equations do have just one solution. So we call those conditional. Sometimes an equation will have infinitely many solutions. It means no matter what value you replace the variable with, it's going to balance. Those are called identities. And you will identify the answer by using this negative to positive infinity. It's called interval notation. Or you can use kind of a funny symbol for real numbers, which is a funny capital R symbol. But the way you're going to recognize it is when you're working the equation, you're going to come out with something that's true, but the variables are going to be gone. So you may end up with 5 equals 5, or negative 7 equals negative 7, or in this case 0 equals 0. When that happens, you know you have an identity. And the third thing that can happen is that you can come up with an equation that is never true, or it's false. You're going to get this contradictory value, something like 14 equals 8 or 0 equals 2. That's going to be a contradiction, and that's going to have no solution at all. So we're going to work one of each of those types so you can see how those work out. Here's your summary chart. I'll leave that visible while I work quickly here. Here's my left, right side. Let me put that in there. And I'll begin by doing the distribution here over the parentheses. And I'm noticing, as I did in some previous ones, that there are a couple of terms on the left-hand side that can be combined. Just to shorten it a little bit, and now I'm moving that constant term 3 over to the right-hand side and dividing by this numerical coefficient on the variable x. I end up with 0 divided by 6, which is 0. And of course I didn't write this down, but you can see how those cancel out, and I end up with x equals 0. So this is conditional. The variable did not drop out. We got an answer. It's a 0 answer, but it's still an answer. So conditional, a finite number of solutions. All right, here's the second one. Again, let me be sure I understand left and right. So I'll put in my dotted line there. Nothing to do on the left except copy it down. On the right, I need to do this distributive. And now I'm going to start moving things around, so I'm going to add 2x to both sides. And you can notice right here that when I add the 2x to the right side to get this 0x, the same thing happens on the other side. So the variables now have dropped out, and I've got a positive 13 on the left and a positive 14 on the right. And we all know that 13 and 14 are not equal to each other. So that's a statement that is not true. When that happens, you know you have a contradiction, because 13 is not equal to 14. That means that this particular equation has absolutely no solutions. There's no value for x that could be put into this equation and cause it to check. So we've seen conditional, where we got a specific answer. We've seen a contradiction where the variables dropped out and we got an untrue 13 equals 14. And you can probably guess what this last one is going to be, but let me show you how it works out. So using my distributive property over this parentheses, copy down the 4x, use the distributive property over this parentheses, copy down the positive x. Okay, now you're going to start looking around, and I'm noticing on the left-hand side I've got a couple of variable terms that could be combined. Same thing here on the right-hand side. So let me compress this equation a little bit by combining those like terms. And right there you can see that the left side of this equation and the right side of this equation match. You could call it an identity right there, but I'm going to go ahead and show you how it would work out. Let's say I subtract the 7x in an effort to get the variable terms together on the same side. So that zeroes out. I have a -6 here. I have a -6 there. That's true, but there are no variables, right? So I got a true statement, but it doesn't say x equals -6. It just says -6 equals -6. So this is one that is called an identity. And I think you can see where it gets that name, identity. And this one has infinitely many solutions. What that means is no matter the value you put in that equation for x, you can put in a 5, you can put in a -3, you can put in a 14, you can put in a -600. No matter what value you put into that equation for x, it's going to check. It's an identity.